Welcome back to Notes Architecture. Today we are going to challenge a highly classic, yet easily messed up intersection of the entire building envelope, the eaves detail. If you look closely at this drawing, it is a very advanced construction. On the inside, the designer wants to expose a beautiful timber roof frame. On the outside, there is a highly textured facing brickwork. How do we draw such a complex detail? If you have no clue, please remember my method. Draw it exactly according to the real construction sequence, from the main structural frame to the completion of the roof insulation, and finally laying the exterior facade. As long as you follow the logic of how builders actually construct a house, even the most complex details will become perfectly clear. Grab your pen and paper and let's get started right away. Step 1. Let's build the load-bearing skeleton first. How does the roof grab onto the wall? We first draw the vertical load-bearing wall. To withstand the massive outward thrust from the roof, a reinforced concrete ring beam is usually cast at the top of the load-bearing wall. On top of this ring beam, we bolt down a horizontal timber beam called a wall plate. It acts as the foundation for the roof. At this point, the structural skeletons of the roof and the wall are tightly locked together. Step 2. Laying the airtight layer, which is what we often call the first red line. First, lay the timber sheathing flat on the rafters. But absolutely do not put the insulation down just yet. We must immediately lay a vapor barrier on top of the timber boards, responsible for blocking indoor moisture. Following the slanted roof downwards, what should we do when it meets this wooden wall plate? Many beginners will just draw it disconnected here, which is a huge mistake. In actual construction, as this membrane runs down the roof and meets the inner leaf load-bearing wall, workers must use specialized airtight tape to seal it tightly against the wall. Only with a seamless connection can the airtightness of the entire building be considered successful. Otherwise, heat and moisture will leak through the gaps at the eaves. Step 3. Bringing in the insulation and the second red line. Putting on the thermal winter coat. The skeleton is up, and now we need to dress the building. The core principle of this step is the insulation layer must absolutely not be broken. We first fill the space between the slanted rafters with insulation. Looking further down, the exterior wall also has its external thermal insulation layer. At this eaves intersection, the roof insulation must extend downwards, and the wall insulation must extend upwards. The two must tightly meet and press against each other right beneath the rafters. If any gap is left here, cold air will blow right through the structure, creating a dreadful thermal bridge. Therefore, on this detail drawing, your yellow insulation line must be perfectly closed. Next, the roofers start laying. Today's second red line, the sarking membrane. It tightly hugs the cold side, protecting the roof like a raincoat. It blocks the rain from the outside while allowing any trace amounts of moisture within the insulation to escape. Step 4. The completion of the roof system and opening up the breathing channel. With the waterproofing membrane in place, we install the counter battens, which creates a crucial roof ventilation gap. Subsequently, the roof battens are nailed on horizontally. Finally, cover it all with roof tiles. At this point, the entire roof is completely finished. It is not only warm, but also rainproof and breathable. Now, safe from wind and rain, we can confidently proceed to work on the exterior wall. Step 5. The completion of the facade system, which is also the final outerwear for the whole building. The roof is done, so we move back to the wall. Tightly against the load-bearing inner wall, we lay the wall insulation. Note that the wall insulation here must fit tightly against the roof insulation, rejecting any thermal bridges. Next, we embed stainless steel cavity wall ties into the wall. On the outside of the insulation layer, we need to leave a gap of at least 2 centimeters, which is the ventilation gap. This layer of air keeps the wall dry. Finally, the wall ties pass through the ventilation gap to firmly hold the gorgeous outermost, facing brickwork. Look, when you draw entirely following this real construction sequence, internal load-bearing skeleton and exposed roof, airtight redline, roof insulation and waterproofing. Roofing tiles completed, exterior brick wall. Don't all these complex material layers suddenly become perfectly logical and highly rigorous? If you found today's detail notes helpful, don't forget to like, save, and subscribe to Notes Architecture. Every Monday, I will use actual construction details to break down the most confusing construction knowledge. Let's level up our detailing skills together. See you next time.